everyone. Welcome to SimStack, an intuitive workflow framework. My name is Celso and I'm part of the workflow group in the MaterialDigital project. In this tutorial, we are going to learn how to use SimStack to build simple and complex workflows. But before we get into the hands-on section, we take an overview of the workflow framework concept. Then let's see what's coming up. Here, I want to explore the H2 potential surface workflow, which I will use to present some workflow framework concept. Over here, I want to highlight the benefits when you use workflow framework to manage the simulation protocols. And why should you use SimStack instead of another tool as workflow framework solution? At this point, I will introduce the physics problem to be addressed during the hands-on section. At the end of this presentation, I want to tell you a short story about why it's a good idea to use SimStack to manage our simulation protocols. Then let's jump in. This slide shows a workflow developed for computing the potential energy surface for the H2 molecule. As you can see, the workflow is composed of 4 nodes. The first one contains a set of internuclear distance for hydrogen atoms. We pass the set of variables for the second part, composed of the for each loop control already embedded in SimStack, combined with the DFT code used to compute the dissociation energy. Of course, as you can see here, we choose QuantEspresso as the FT code, but you can replace it with your favorite one. The remaining 2 nodes are responsible for handling the outcome data from the second part, and they, of course, plot the potential energy surface like we did here in this example for the H2 molecule. Of course, you can reuse this at the end. You can reuse this workflow to compute this property for different systems. In this case, you could run for nitrogen 2, oxygen 2, fluorine, chlorine, and so on. Essentially speaking, you are ready to reuse it by just doing simple geometry and chemical species change. With that, you are good to go and run for the system that you are interested in. At this point, we want to present some benefits of using workflow framework. There are several ones, but here we focus only on 3 of them. The first one, automation. Automation is always related to how the information changes and flows along the workflow. The information on the workflows moves according to the interdependencies, collecting the output of preceding steps and pass part of them or all of them as input to the subsequent ones. Usually, the data flows from the top to the bottom until it reaches its last node. Let's come back to our H2 potential energy surface workflow example. In this workflow, we start by defining a set of internuclear distance in the first node, which is used as input to the second part. Then all the information generated here feeds the last 2 nodes. So in this sense, the information is flowing from the top to the bottom, right? Second, data reusability and the complexity reduction. Workflows often reuse data in subsequent steps. Once we have pre-built workflows, they permit computational expert and the non-expert to generate high-quality data on the same level, allowing them to focus on the science instead of the procedure. Suppose that an experimental team has found a new diatomic molecule and they want to compute the potential energy surface for this molecule via this workflow here, for example. This team has 2 options. They can ask a computational expert to perform the calculation, or they can do it by themselves if they have the workflow, of course. But in both cases, the quality of the data will be the same. It doesn't matter who will be conducting the simulation. Third, rapid prototype. The rapid prototype speeds up the modeling development. These benefits enable multi-scale modeling by reusing existing code. For example, in SimStack, this is done by just simply drag and drop the nodes from the nodes area to the main canvas area here. You could, for example, instead of use QuantEspresso here, you could use VASP, TurboMod, or any other DFT code. But life is not a bed of roses, right? Even with these significant advantages, many academic groups still rely on script-based approach to implement increasingly complex computational protocols. And why so that? Maybe this is because of the lack of information on existing workflow frameworks in physics, chemistry, material science, and natural science in general. Another possible reason would be the effort needed to do this step, moving from the script-based to the workflow mindset. But regardless of the reason, the truth is that the daily amount of data and the complexity related to a published simulation protocols only increase. And naturally, there will be a point where the majority of the groups working in material modeling, and in particular those in multi-scale domain, will have to move to the workflow framework world. If you see yourself in this situation, don't worry, SimStack can help you to go over this barrier. Here we have the SimStack overview. The building blocks in SimStack are named workflow active nodes, or in short, venues, which is specified in an XML file, where we define the exposed parameter to be displayed on the GUI, as well the input and output file. SimStack uses the venues to render the information from your local machine to your HPC resource. Here we have some venues example, and the incorporation of those new models are very easy, and you can do this in matter of minutes. Let's take a look to see how this XML file looks like. For example, here we have a venue template where you can define some metadata here, like your email, description of your system. And here in this venue root, you can load the input file that you need to run your calculation and define the set of parameters that you want to expose. And here is where you run your simulation itself. And this part here is responsible by load your input file. And here is where you define your expected output file. So, and beyond of that, SimStack has this very nice feature that you are able to drag and drop those venues to the main canvas area to construct, to build up your workflow. Let's see in SimStack how it looks like. You can just click here and drag and drop here in the main canvas area, and click on it. This is going to expose to you the parameter that you are allowed to change. And here, for example, you have the system. This is for the projectile motion. Essentially speaking, it has the initial position in the X and the Y, initial velocity, mass of the ball, angle, initial angle of the ball, and the radius, and the label. Here, this label is important because you can have several set of parameters, and then you can just put label 0, for example, label 1, and so on. In that way, you can keep track of the information, right? So let's go back to the presentation here, and of course you can connect code from many sources, many different code from many sources, and you can connect to your HPC by just clicking a button. For example, here now we have this red button here. This is responsible by connecting your local machine to your HPC resource, and if you click on it, now it's red. That means it's not connected, but it's going to be green, and when it's green, it's connected. Now it's connected, right? So you have those many advantages that you can use, and it's going to help you a lot to construct your workflow. Here we have the projectile motion venue that I want to talk a little bit. Essentially speaking, this venue is responsible by solving the physics of our problem. Here we have, for example, the ball that's moving this direction here. And against the ball, we may have, for example, drag effect, that essentially speaking is air resistance effect. And if the ball has this backspin rotation here, you might have lift as well. And you always is going to have weight, right? So let's go back to SimStack to see the exposed parameter I already mentioned before. And here we have those set of parameters. And the system, you can have a smooth ball plus drag, golf ball plus drag, and the lift effect, and so on. So in the end of the hands-on, we should be able to construct this workflow here. This is a branched workflow where we have, for example, a condition here, and based on this condition, we can run this side of the workflow or this side here. In the end, this is a very simple example, but just to show you that it's possible with branch workflow with SimStack. As I promised at the beginning of the presentation, I want to show you why using SimStack to manage your scientific workflow is a good idea. Suppose that you found this Mario Bros game a very interesting game and you want to play it. In this case, you put a challenge to yourself and say, okay, I want to pass a level for this game without using the power of the Firefly. After some time, you are going to do some mistakes and learn with those mistakes and pass the level, right? Suppose now that you change your mind and say, okay, now I want to use the power for the Firefly. In this situation, what do we expect? Do we expect spend less time than before? Why? Because now you have the power of the Firefly, and this will prevent you to die early during the match, right? This is the same here when you are a PhD student. Of course, we don't expect you to die during your PhD. Suppose that you have a scientific workflow and you want to solve during your PhD, and suppose now that you have the help of SimStack to manage your scientific workflow. In this case, SimStack can help you to save time during the development of your project. At the end, you can be a PhD survivor instead of just a PhD candidate. it. I think this is a fair comparison, right? Next, we are going to learn how to install SimStack in Linux and Windows, and we are jumping in the hands-on section. So let's jump in.